Hi, I'm Mark Barsamian. In this video, I'll be introducing the method of integration by substitution. This material is from section 5.2 of the book. More specifically, a lot of pages, but no exact match of examples for what we're doing in this video. The corresponding homework is this collection of 4 exercises from section 5.2. Remember that the chain rule for derivatives is used for taking the derivative of nested functions, that is, functions of this form, outer parentheses, inner parentheses, x. And the chain rule says the derivative of one of those functions is obtained by doing this: outer parentheses, inner parentheses, x times inner prime of x. The goal now is to find the general antiderivative of a function f of x that involves a nested function. That is, we wish to find this indefinite integral where the integrand f of x involves a nested function. This is not always possible, but sometimes it is, using a method called the substitution method. Here is my substitution method for finding the indefinite integral. I'm going to call that capital F of x, the indefinite integral of little f of x, where the integrand, little f of x, involves a nested function. My method is these 5 steps. Now, I won't go through this method in detail right now because it would just seem too abstract and not helpful to try to go through this method. What I'll do is we'll just dive into examples, and I'll continually come back to this method and see how it tells us how to do those examples. Example 1a, find this indefinite integral. Now let's identify the integrand. That's the integrand. We've pulled it out and written it by itself. So let's follow the procedure from the substitution method a couple pages back. Step 1, identify the inner function and call it u. Write the equation inner of x equals u to introduce the single letter u that's going to represent the inner function. And furthermore, circle that equation. Well, what is the inner function? It's going to be the function that's sitting inside of some other function. Well, you see in this expression for the integrand, there's a function sitting inside of another function. That thing on the inside is what we'll call the inner function. And that's the thing that we'll name u. And that's the equation that we'll circle in green. That's step 1. Let's go up and see what step 2 says. Step 2 says, build the equation dx equals 1 over u prime du. To do this, first find u prime, and then use it to build the equation dx equals 1 over u prime du, and circle that equation. And I'll circle that equation in red. So there's our equation of the form dx equals 1 over u prime du. I started by using my u to find u prime. U prime is just the derivative of u. And then I built that equation, and now I'm supposed to circle that. I'll circle that equation in red. Let's go back up and see what step 3 is. Step 3 is substitute, cancel, simplify. In steps 1 and 2, we have 2 circled equations. Substitute these into the integrand of our indefinite integral, cancel as much as possible, and then simplify by using the constant multiple rule. The result should be a new basic integral involving just the variable u. So substitute, cancel, simplify. So there I've substituted. Notice that I used this green circled equation to make this green substitution. And I used this red circled equation to make this red substitution. So that's my substitute part. Then the cancel part. I was able to cancel this 6x to the fifth with this 6x to the fifth. Now what about the simplifying? What's up with that? Well, look at that. We've got now a basic integral involving just u. In my instructions for step 3, it said the result should be a new basic integral involving just the variable u. We've got one of those, so actually there's no simplifying to be done here. So there's no simplifying that needs to be done. Now, if you go back up to the description of today's homework, it's basic substitution integrals with no multiplicative constant after substitution. That is referring to the step that we just got to, where there's no simplifying to be done. So in the examples that I'll be doing today, we will always do the substitute, cancel, and simplify step, but there won't actually be any simplifying to be done. So we've done step 3. We've reached this new basic integral involving just the variable u. Now we're ready to go on to step 4. Step 4 is to integrate. Find the new indefinite integral just by using the indefinite integral rules. The result should be a function involving just the variable u with the constant of integration, plus c. Okay, so step 4 is integrate. And there's our new function involving just u, and it has a constant of integration. That 5 should be an exponent. That's step 4. Let's go up and see what step 5 is. Step 5 says substitute back. That is, substitute u equals inner of x into the function from step 4. That's this same green circled equation. So there you can see the substitution, substituting back using this same green circled equation. Let's go back up and see what the instructions say about what we're supposed to do here. So we substituted back. The result will be a new function of just the variable x. And we have to remember to include the constant of integration. This is the capital F of x that we seek. Remember, the goal was to find this indefinite integral. We can call that capital F of x. Now I want to write a clearer conclusion to make it a little bit more clear what we did. I've kind of run out of room here, but I don't want to start a new page, so I'm just going to shrink all this a little bit. So there's our conclusion. The indefinite integral that we were assigned to do equals this. Remember, the indefinite integral stands for the general antiderivative. A couple of things to notice about this. Remember that we integrated in step 4, and immediately after the integration symbol went away, the plus c shows up. Other things to notice. The result of step 3 is this indefinite integral involving u. It does not have any x's in it. Also, notice that it's a sort of grammatically correct integral in that it has the integral symbol, including this s-like thing, and the du. It doesn't have a dx, it has a du. So let's go back up and make sure we've done everything. We substituted back. We labeled our result as capital F of x, and that is all that we need to do. So that's the end of that example. Let's go on. Question B. Find this indefinite integral. Now, I have this typeset in kind of a peculiar way. I don't actually like this typesetting, but I have it typeset this way because this is the way the book typesets a problem like this. Now, the reason I don't like this is, let's go back up and look at our substitution method. The first step in the substitution method is identify the inner function and call it u. And we have this circled expression, inner of x equals u. And remember our first example of substitution. In this first example, we identified the inner function easily. It was the thing sitting inside of the parentheses. And in fact, that's usually going to be the way that it works. You want to look for the inner function, and it's most often going to be the thing that's sitting inside of the parentheses. Well, in this example, those parentheses are misleading. The thing inside of the parentheses is not the inner function. In fact, those parentheses don't even need to be there. So a better way of writing the integrand would be the following. So a more helpful way of writing the integrand is to not use parentheses around the 4x cubed. It doesn't need to have parentheses around it. And then to replace the square root symbol with the parentheses to the 1/2 power, because that's actually going to be the way that we deal with the square root. We're going to think of it as a power function. So now we're ready to follow the procedure. Let's go back up and look at the procedure again. Step 1 is identify the inner function and call it u. So our integral has now become the following. So our step 1 is to identify the inner function and call it u. And we should circle that equation. Now let's go up and see what our step 2 is. Step 2 is to build the equation dx equals 1 over u prime du and circle it. There's our equation, dx equals 1 over u prime du. That's step 2. Let's go up and check our procedure. We've done step 2. So we're ready for step 3. Step 3 is substitute, cancel, simplify. So step 3, substitute, cancel, simplify, we've done. We substituted our green substitution from this equation. We substituted our red substitution from that equation. So that was the substitution step. We did our cancellation. That was these terms canceling each other. And then we had no further simplifying because you can see our result is a basic integral involving just u and no x's. The result of step 3 is to be a new basic integral involving just the variable u. And again, we didn't have any simplifying to do because in the examples for today and in your homework corresponding to this video, there won't be any more simplifying to do after you do the cancellation step. So our next step is to integrate. There's a result of integrating. Notice again that as soon as the integration symbol goes away, the plus c shows up. There's a constant of integration in every step after that. Also notice that we had to be very careful to use the power rule correctly. I didn't do that arithmetic in my head at the first step. I just wrote down that arithmetic that was going to be done. 1/2 plus 1 is 3/2. That's not terribly difficult. But if you skip this step and try to go from here to here in your head, it's very common for students to make mistakes there. And then finally, we use the fact that dividing by 3/2 is the same as multiplying by 2/3. Now what's our next step? We've done step 4. Step 5 is to substitute back. Make the green substitution. Now when we substitute back, we're going to have our result. So I'm going to go ahead and write the integral equation. So you can see that we substituted, replacing that green circled u with this green circled expression, according to that circled equation we had earlier. And we wrote the final conclusion showing the original integral. Now I didn't show the original integral with the wacky typesetting of the book. I like this typesetting better here, and I'm just going to stick with that. And then the result that we got, remember, is the general antiderivative. It's this function form. That's the end of that example. Question C, find this indefinite integral. Now, that's typeset the way the book typesets it. I like to typeset this in a more helpful way because this fraction actually causes some headaches. So I want to start by rewriting the integrand. There I've written the integral with the x written as 1 over x instead of appearing in the denominator. That'll actually make the solution a little bit clearer. So let's do our procedure. Step 1 is to identify the inner function and call it u. Well, the inner function is the thing that's sitting inside of the parentheses. There. So we write that equation and we circle it. Step 2, let's go back up and look at our instructions for step 2. Step 2 is to build the equation dx equals 1 over u prime du. Now remember the procedure. The procedure is first find u prime, then build the equation. So there's our equation. Dx equals 1 over x du simplifies to just simply dx equals x times du. Okay, let's go back up and see our procedure. So we did step 1, we did step 2. Now we're ready for step 3. Substitute, cancel, simplify. So we write down our integral and then do the substitutions. So there you can see we used our green equation, a green circled equation, to do the green substitution there. We replaced ln of x with u. We used our red circled equation to do the red substitution, replacing dx with x du. That's the substitute part of this step. Next we do the cancellation part of this step. We can see that those x's cancel each other. And we're left with this basic integral, u to the 13th du. There's no further simplification needed. So that's step 3. Let's go back up and see what step 4 is. We did step 3. Step 4 is to integrate. There is a result of the integration. Notice again that the plus c shows up immediately after the integration symbol goes away. And then the plus c is carried on throughout all the rest of the steps. Okay, let's go up and see what's next. We did step 4. Finally, step 5 is to substitute back. Now we know that when we substitute back, then we will have our final answer. So we should write an equation that describes what we did. So there you can see the substitution that we did. We used our green circled equation to replace that green circled u with this green circled ln of x. So then we're left with this new expression, which is a function, which is the general antiderivative. So that is the result of that indefinite integral. The indefinite integral is the general antiderivative. That's the end of that example. Let's go on. Find this indefinite integral. Well, this is one, again, where the book has typeset this in an unhelpful way. I'm going to write this in a more helpful way. Now you'll see why in the very first step. Step 1, remember, is to identify the inner function and call it u. Well, you can see that the way I have this written, it's clear what the inner function is. The inner function is that 5x minus 7. You can see that in the original presentation of the problem, the parentheses were unhelpful. They're misleading. The thing inside of the parentheses is that number 5. That's not the inner function. And those parentheses around the 5 don't even need to be there. So it's really important when you do these problems that are presented in the book, in the MyLab system, that you scrutinize carefully the presentation of the integrand and see if it's really written in a smart way. So back to our job. Our job is to identify the inner function and call it u. There we go. There's our equation. We circle that green. Step 2 is to build that strange equation. So we first find u prime. So u prime is 5. Now we build the equation. And we circle it in red. Step 3, remember, is substitute, cancel, simplify. So there you can see we did the green substitution and the red substitution. We canceled. These 5s cancel each other. We end up with this new basic integral with no further simplification needed. Notice I did not write that as a power function. I want to leave that as 1 over u because remember, if I wrote that as a power function, it would be u to the minus 1. The power rule for indefinite integrals cannot be used with the power of negative 1. So we have to leave that as 1 over u. Step 4 is to integrate. Well, the indefinite integral of 1 over u is ln of absolute value of u plus c. Step 5, we substitute back. Now when we do that, then we're going to have our indefinite integral result. So I'm going to go ahead and present this as an integral equation. And there's our result. You can see that we did the green substitution and we obtained this function form, which is the general antiderivative, that is what that integral stands for. That's the end of that example. We have one more example. Question E, find this indefinite integral. Well, this is another one where the book has typeset this in a misleading and unhelpful way. So I'm going to start by rewriting the integrand. The parentheses around the 3x squared don't need to be there, and they're misleading. All right, let's do our substitution method. Step 1 is to identify the inner function and call it u. So our inner function is the thing inside of parentheses, which is just that x cubed. And again, you can see why the original typesetting is very misleading. Looking at that typesetting from the book, you might wonder if the x cubed is the function inside or if the 3x squared is the function inside. There's no ambiguity. The only parentheses that are needed are the ones around the x cubed. Step 2, we build that strange equation. Well, we start by finding u prime. There's our u prime. Now we use that to build the equation. And we circle that equation in red. Step 3 is substitute, cancel, simplify. There's the result of step 3. Notice that we did our green substitution using this equation, substituted that u in place of that x cubed. We did our red substitution using this red circled equation to replace this red circled dx with this red circled stuff. We canceled. The 3x squared canceled the 3x squared. And then there was no further simplifying needed. And note that the result of step 3 is this integral, which is a basic indefinite integral, only involving u, no x's. Notice that it has all of the correct symbols. It has the integration symbol that consists of the s-like symbol and the du instead of a dx. Now we're on to step 4, which is to integrate. And then step 5, substitute back. And remember that when we substitute back, then we will have done the problem. So I will present this as an integral equation showing our result. So you can see that we use the green circled equation again to substitute back, replacing u with x cubed, resulting in this function form, e to the x cubed plus c. In that function form is what's represented by this integral symbol. That indefinite integral is this function form. That's the end of the example, and that's the end of the video. Thank you.